Today we will be talking about engineering, education and practice. Okay, like I said, the slides are uploaded. Those who have access can open them and be with me, but otherwise we will just work it out. Okay, so in this topic we will be trying to cover what engineers basically do and why they are important for the society, what they are contributing towards other people, okay, and what it means to think and act like a professional. Okay, so when I spoke about it last time as well, when you get the shahada, the degree, the certificate, okay, it's not a piece of paper, it is supposed to change yourself. Okay, you are like what you were before the certificate and what you are after the certificate should be different. Okay, so there are certain things which you need to have when you become a professional. Okay, and some of those things I already mentioned, and the things which we will discuss for being a professional, they are common to most of the professions. Okay, so still the things which we talked about last time, public speaking, body language, not blaming others, they are general. Okay, an engineer shouldn't do it, a doctor shouldn't do it, a lawyer shouldn't do it. Got it? A lawyer should be confident, an engineer should be confident, a doctor should be confident, so on and so forth. Okay, so what we are discussing in terms of being a professional is common to all professions, whether you are an engineer, doctor, policeman, and whatever. Okay, so the aim of discussing this at this stage. Some of you may say, when we will become engineers, we will see, right? Or we will know. That the thing is, you need to prepare yourselves for becoming an engineer right from now. Okay, so you should not take these courses and these things lightly. Okay, they are supposed to prepare you for your professional life. Okay, but it cannot happen if you are thinking in your mind, oh, I'm still a student. Okay, you are a student, but like I said, it's just a matter of time before you switch from one role to the other role. Okay, before you switch from being a student to being a professional, and it doesn't happen overnight. Okay, that tomorrow I will have my final result. Okay, and like a Spider-Man, I will change in a minute. That happens only in movies, right? Only even there it doesn't happen. It's just making you feel like it, right? So it doesn't happen overnight. So you have to think from now what qualities I need to become a professional, and you need to develop these qualities starting from now. Okay, so if somebody has problem in public speaking, somebody has this mentality of blaming others, somebody has a problem with body language, okay, if they don't work on it now, they will remain the same even after they get the certificate. Understood? Makes sense? Okay, so you need to start changing yourself, or you need to start looking at yourself as being a professional. Okay, one thing which I keep on quoting, that was from our like you have the president of the university, right? So he is sort of the president of when we were in our first day of the university, first day, we did not even attend any lecture. So we were supposed to have this introduction. Okay, and we call him the vice chancellor, like you call the president. Okay, in our university in Pakistan, the big boss of the university is called the vice chancellor. Okay, so he came, okay, and the first words he said was, ladies and gentlemen. Okay, and then he explained that you are no longer boys and girls. Okay, you are now ladies and gentlemen, meaning ladies and gentlemen behave properly, they take responsibility. Okay, they can speak for themselves. Okay, you are no longer boys and girls of school. that your teacher has to take care of everything. Got it? Clear? Okay, so you need to keep this message in mind. I keep on quoting this because I like it. Okay. So first of all, what is the importance of engineer in the society? Okay, so engineering is one of the most important professions in the modern society. It has been important since many centuries, but even in the modern society, the importance is still there. Okay, what do we do as engineer? Okay, we design things, we build them, we operate them, and we maintain them. Okay, so on daily basis we are doing one or many of these things. Okay, so first of all we design how this thing, how this product, how this service should look like. Okay, so we make all the design, the dimensions, the weight, the properties, okay, the load and all these things. Okay, so we design it ourselves. Okay, then we build it. So we have the drawing, okay, and then we go onto the site and we start making this thing happen. Okay, we make sure now that this thing is available. Okay, how this product or this thing or this structure, okay, we build it physically now. Okay, so building is also, or in some other terms we also call it execution of the design. So we design it and then we execute the design, meaning we build that thing which we have designed. Okay, then we operate. Okay, so operate means to use. Okay, so somebody must have designed this, somebody must have built it, right? Okay, did I design it? No. Did I build it? No. I am doing what? I am doing what now? I am operating it, right? I am just using it. The same thing with the laptop, right? Did I design it? No. Did I build it? No. Okay, but I am doing what? I am using it. Okay, so this is building. Okay, now if this goes wrong, if this doesn't work, the screen is not showing anything or something happened to it, then I have to do what? Okay, I have to do the maintenance. Okay, so all these aspects, these are the only aspects which you have in the life cycle of anything, right? It starts from design and then you build it, then you use it, something goes wrong, you maintain it. Okay, you do the maintenance. After maintenance, you go back to which stage? Yeah, operating again. Okay, and then again something will go wrong, and again you operate, maintain and operate. Okay, so this keeps on going, right? And when you can no longer maintain it, when you can no longer do maintenance for it, you throw it, right? So that is the end of the design life, right? When something cannot be maintained and operated, that is the end of the design life, right? So this was the start and this is the end. When this finishes, then the product has finished its lifetime. So in all these stages, engineering is involved. Clear? Okay? But it doesn't mean that all these stages are personally handled by engineers. Right or wrong? Huh? My car goes wrong, my laptop has a problem. I'll not look for a computer engineer, right? Or there's a problem with my car, I will not look for a mechanical engineer. Right? I go for a mechanic, right? Huh? That mechanic can be a mechanical engineer, but some of them look like it. But the point is, behind them, the specialization belongs to an engineering profession. Okay, what they are doing is part of engineering. Okay, they have learned that much part and now they are using it. Clear? Like we do, like we see on the construction sites. Okay, what is happening on the construction site? Who is responsible for the site? The site engineer, right? The site has an engineer, right? But is he doing everything himself? No. Okay, but the other people are part of the same project, so they are part of the same profession. Okay, so in terms of profession, all these things are handled by the engineers. Okay, and what are we designing and building and operating and maintaining? Everything which you look around, right? Everything you can think about is all part of, or it's all a product of some engineering, some type of engineering, right? For example, this building, right? This building was designed by an engineer. It was built by an engineer. Okay, maintaining and operating is part of the engineering profession as well. Okay, what else? Give me other examples. Laptop, car, yes. This is called cheating, right? I already gave you the examples. Think about something yourself. Yes.
The lamp.
Huh?
The lamp.
The land, yes. Everybody wanted to be something else, right? Nobody wanted to be a civil engineer. I got it now. Yes. Something from civil engineering. Okay, go ahead. Okay, fine. This is fine. Yes. Bridges, yes. Roads, yes. What else? What else do we design and build as civil engineers? Bridges, roads, tunnels.
Canals also.
Which one?
Canals.
Canals.
Yes.
Okay, okay. What else? Good example. Yes.
Factors. Factors.
Factories. Yes. What else? I got this water in the bottle, right? Okay. Can they just put any water here? They can, but they won't. Right? So before putting it in the bottle, so I can drink, they should do what? Poison it, huh? Yes. I will not accept anything from you. Yes. Before they put the water in the bottle, they have to do what? Huh? Clean it, right? Okay. So the treatment plants, the water treatment plants, they also come. They are also part of civil engineering profession. Okay. He mentioned you mentioned canals. So canals are open channels. Okay, but they are closed pipes as well, right? And those pipes are not only used for water; they are used for oils and gases and so on. Okay. So all these systems, all this infrastructure comes as a part of civil engineering. Okay. Then we have these phones, right? Okay, we are not building the phones, right? But these phones are part of the communication network, right? Okay, so you need good signals, you need the devices, you need these things. Okay, so installation of communication towers, installation of their fiber, fiber pipelines and so on and so forth. So it's this is all part of the civil engineering. Okay, so from the building to your phone, everything is part of the civil engineering profession. We are involved in these stages of these items. Okay, so the examples which we have given here gives you an idea about the importance. Okay, so the problem is, if the person who was designing this building, he made a mistake in the design, will we be sitting here? Will you guys be sitting here if there was a design in the building, there was a mistake in the building design?
Depends.
It depends, right? Yes. But let's say the design was faulty, he did not consider the roads properly, okay, or he did not design the thickness of the slabs properly. You will have problems, right? Okay, the building will not be usable. Okay, if somebody tried to use it, then what will happen? The person who did the design did not do it properly. Okay, the client did not know. So the building was ready and he started using it. Now what will happen? It will collapse, right? Okay, it will collapse under the load. It will start to deteriorate, right? Now this is causing direct risk to the users of the building, right? Okay, I gave the example of the water system, right? The water cleaning system, the water treatment system. So if that system has a problem, you can see the direct effect is on human health, right? Clear now? Okay. She mentioned roads and bridges. Okay. So if there's a problem with the design of the roads, if there's a problem with the design of the bridge, okay, design or construction, whatever, okay. So it's not as per what it should be. Okay. Either the design is faulty, or either something not done properly in the construction. Okay. Or it has happened recently. I did not see it in my 8-9 years in Berlin, but I then saw it twice in like 2 months. Signal going completely off. Okay, and once on a main highway. The signal was completely off. Okay, so now you can imagine how much problem it can cause on the main highway. The driver is coming at 100 kilometers per hour. Okay, and the signal is off. Okay, you can just imagine how many accidents you can have. Clear or not? Okay, so now this is a problem of what? The other two stages, right? Somebody designed the signal, they installed the signal was working fine. But the person who was operating and maintaining did not do a good job. The signal went off. Okay, same thing with the lane markings, the shoulders, okay, the light poles, okay, not the signal lights, the light poles which you have for nighttime driving, right? So if you have any problems with those, it can cause accidents, right? Okay, so the importance of engineering is that the products, especially civil engineering, that the products which you are making are for public use. Okay, and they are normally used by a large amount of people. We talked about water treatment system, we talked about buildings, we talked about roads, bridges. Okay, so it's not like one person is using it. Okay, at a time they could be, like even in this building, right now there could be hundreds of students here, right? Clear now? So the impacts of what we are doing as civil engineers are affecting the public directly. They are affecting their safety. Okay, so if you make any mistake at any of these stages, the results could be very devastating. Okay, the results could be very dangerous. So either if the mistakes of a civil engineer may have problems or may have results in terms of public safety. For example, the road design. Okay, it can have, if the road is not designed properly, maintained properly, built properly, it can have accidents. Okay, the building, if not designed properly, constructed properly, it can collapse. Okay, so either it can have impact on safety, or it can have an impact on environment. We talked about water cleaning system, right? Okay, so if water cleaning system is used for both drinking water as well as the water which you use, okay, the sewerage, okay, or the rainwater. Okay, so if your water treatment system is not working properly, then you are disposing polluted water into sea or into the land, okay, which is also dangerous. Okay, now we use these plastic bottles, right? Is this good for the environment or bad? Bad, right? Everybody agrees or not? Huh? It's not good for the environment. Okay, so you cannot just throw it off. Okay, if you throw these types of things into the environment, just okay, this is the area where I throw all my dump. Okay, the area where I throw all my garbage. If you do something like this, these things will not only cause damage to the environment of that area. Okay, they go from the ground into the air and they spread. Okay, there are countries which are having problems because of not having a good waste disposal system, and the whole city is facing the problems. Okay, just because of one area or just because of what you are throwing in the sea. Okay, so the mistakes of an engineer can affect safety, they may affect environment, or they may affect your quality of life. Okay, even if you are not harmed, if you are completely healthy, okay, and the problem is not doing anything with the environment, it may still affect your quality of life. Okay, I gave you a very good example, which was for this is our quality of life, right? Huh? The network is good, life is good. Huh? If the network is working, everything is working. Okay? So for example, the communication towers or the communication lines which they have installed, there is a problem with that. Okay, so it will not do anything harmful for the environment. In fact, it would be good. For the first time in your life, you may see what is happening in the outside world. Okay, so it is not affecting the environment. It is not affecting safety as well. Again, it could be good that you will pay attention to the road instead of your phone, right? It would be good for the safety. But what about the quality of life? You will not feel the same thing, right? Okay. Same thing with again, my area's transportation, so I will keep on going in that direction. So if the road design is not proper, maybe it's not causing accidents, maybe. Okay, but it's causing a very long traffic jam for hours. Okay, so maybe it's not affecting safety, but it's still affecting your quality of life. Okay, so because engineering, especially civil engineering, are dealing with products and things which are used by public at large. Okay, they are used by people on a large scale. So any mistake which they make in any part of the product life cycle, it can affect either safety of the people, it can affect environment. The environment is general. When we say environment is not restricted. Okay, it will only destroy the environment of this room. There is no such thing like this. Okay, when you do something harmful for the environment, it will spread. Okay, so it can be harmful for the environment, it can be degrading for the quality of life. Okay, so that's why going back to the point which I made at the start, you need to think about yourselves as responsible professionals. Okay, when you are studying now, you need to think that if I don't study it properly, and if I have to do the same thing in my life later on, so my mistake can do what? Just imagine. Okay, so I have a subject which is in structures, okay, or I have a subject which is in water resources. Okay, I don't like this subject because they gave it to Dr. Oni to teach it, and don't like him. Okay, or I don't know what he is saying. Agreed? No? Okay, so, but because of any reason, okay, you did not study it well, and you pass with B, C, whatever, you still considered pass. Okay. You are good in other subjects, you will still get the degree. But that lacking can do what in future? Just think about it. Okay, so don't think about your studies as just going through it. Okay, I'll just go through it. Okay, I got B here, I will get A in this subject. This course is very easy. This course is very easy, right? I'll get A in this one. Maybe I'll get B plus in some other course. It's fine. In the end, everybody will graduate. Inshallah, right? You guys are not saying inshallah. Huh? Even if you say inshallah, who believes you, right? Huh? Yes. So you need to focus on the courses from this aspect. Okay, that what I am studying now will affect people later on. Okay, if I don't know about this thing, so my mistake can cause accidents, my mistakes can cause lives, my mistake can cause environmental damage, my mistake can cause mental stress to people and so on and so forth. Okay, so you need to think about what will happen to you because of your mistake in the future. Okay. Okay, who can give me like a one line about what is engineering? You all took admission in civil engineering, right? Part of engineering. So what did you think about it? Or what do you think about it? What is engineering?
Solve problems.
Solving problems. Very good. What else?
Thinking outside the box.
Huh?
Thinking outside the box.
Thinking outside the box. Okay. Anything else? Yes. Anybody else? You can say anything. No problem. Yes. You want to say something? Huh? Yes.
Find solutions.
Huh?
Find solutions.
Finding solution. Yes.
Make things work.
Make things work.
Avoiding mistakes.
Avoiding mistakes. This is engineering.
They should be.
Should be. Yeah. Yes. Anybody else? Okay. In your high school, they give you two choices, right? Like which type of subjects you can choose, right? Okay. What are those choices? In your high school, they give you two different tracks, right? Something like this. You have to choose. If I go in this track, I can take engineering. If I don't take this track, I cannot take engineering. Something like this, right? So which track did you guys take? Science, right? Okay, science. And what is science? What do you study in science? Chemistry, physics, and maths, right? Okay. So if somebody didn't take these subjects, then they would have problems with engineering, right? Okay. So engineering is linked with science as well. Okay. So okay, so we said that for engineering we need science, right? Okay, so what is engineering? It is the application of science. Okay, and science is what you guys just said. Okay, it's a part of physics and chemistry and mathematical rules and regulations. Okay, rules and equations and so on. Okay, so when you apply them to do what? To do what? What did you say? What is engineering? Solving problems. Okay, so when you apply science in real life to solve problems, that is engineering. So solution and should be real. So we are applying science to solve any problem in real life. Okay, if you can just do it on a screen, that is a movie or AI, right? I can do this, do that. Oh, everything is so nice. I'm receiving some AI generated pictures and videos about my old town from Karachi, showing snow at every. Yes, at least you do something which someone can believe, right? Snow. Karachi is same like Bahrain. Temperatures are very close. So just imagine somebody sent you a picture of Bahrain, there's snow everywhere. Yes. Okay. In engineering, we are not looking for the correct answers. Okay, we are looking for something which can be safe, efficient, economic, and practical. They are interlinked. Economic and practical and efficient, they are interlinked. Okay, so what is the correct answer? For example, somebody uses an equation to calculate the let's say the length of the length of steel. That's it. Okay, so if they use an equation, okay, and the equation gives a negative answer. Okay, can the length of steel be negative? He is thinking. This is called negative thinking. Okay, can the length be negative? No. Okay, but the equation gives an answer. Okay, they come and check again equation. They check the equation. They get the same answer. The answer is correct. Yes, correct. You cannot get anything else. You are using the same equation. It has this A, B, C, and D. Okay, you are putting A, B, and C, and D, and you are getting a negative result. So the answer is correct. Okay, if this happened in the exam and you got a negative answer, okay, the teacher cannot give you 0 because this is what he is looking for, right? Okay, but can you do the same thing in your field? No. Okay, so we are not looking for correct answers. We are looking for something which will be safe. We already talked about safety, right? So, for example, somebody says that, or I will talk about it later. But safety is, you see the order, right? You see their order. So their order is our prioritization. So what is our highest priority? Safety. Okay, safety could be for people. Safety could be for the environment as well. If something bad is happening with the environment, that is also affecting people, right? Okay, so safety in both aspects. So if it is not safe, we cannot do it at all. No. Okay, there's no such thing here. We will take a chance, or maybe, or we will see. There's no such thing like this. Okay, so when it comes to safety, we don't take chances. Okay, so this is our top priority. Okay, the second one and this one, they are interlinked, and economy is also linked with practicalness as well. So what is efficiency? Efficiency is a ratio, right? Efficiency is a ratio. Ratio of what? How do we define efficiency? Something is efficient, something is not efficient. Somebody is more efficient, somebody is less efficient. What do we mean?
The quality,
Maybe
the quality.
the quality, okay. Good. What else?
If it's solving the problem or not.
Solving the problem, okay. What else?
Maybe
Technical what?
like you can use it.
Helpful or not. Helpful or not. If it's helpful or not.
If it is helpful or not, okay. In the field, when you go in the field, you will find.
Organization. Make work more organized.
Yes. So you may have different options to do the same thing. Okay. So, for example, you can have steel bridges, you can have concrete bridges. You see this the slab. The slab can be done on the site, or it can be precast. Okay. You can do it with steel. You can put steel inside the slab, or you can do it without steel. Okay, you can just do it with concrete. Okay, so there are many options. All these options can be made safe. So I assume that my concrete will not have steel at all. I can still do the design. I can still do a safe design. Okay, but will that design be more efficient? So this is how I look at the options. Okay, going back to the correct thing, we are not looking for the correct answer. Okay, somebody may do a steel bridge design somebody else may do concrete bridge design, and both of them will say my design is safe, and this is possible. You can make a design safe using steel, you can make a design safe using concrete. Okay, you may have seen bridges which are made up of wood, right or wrong? Okay, again, taking the example of Pakistan, we have bridges. Okay, if you walk on it, they start shaking. Okay, because they are made up of wood planks and ropes only. Okay, wood planks and ropes only. And on these bridges, on those bridges, sometimes they go on jeeps, cars. Imagine. The design is safe. Okay, the design is safe. It's bearing the load, right? What else is safety? If it can take the load, it's safe. Clear? Okay, but what are there other options to make the same bridge? Yes. Okay, so then we have to look at which option is more efficient. Okay, so I was saying efficiency is a ratio of output upon input. Okay, efficiency is the ratio of how much you are getting and how much you are putting. Okay, if I can get a phone which is very cheap, but it has lots of memory, it has very good speed and very good camera, and what else, I don't know, what else do you look at? So it has all the good features, but the price is very low. Okay, I have another phone which has less features and the price is also very high. Okay, so which one is more efficient? The cheaper one, right? So which one will you buy? iPhone, right? The cheapest one. I do the survey, 80% of the iPhone, right? Huh? What? No, I don't have to show. Okay. You get the point, right? Efficiency is how do I do the same thing with less input? How do I do the same thing with more efficiency? Okay, so on an intersection, you can have a signal, you can have a roundabout, you can have a stop sign, right? Which one is more efficient? Okay, which one will solve the problem better? You can have a road of 2 lanes or 3 lanes. Which one is better for the traffic? Okay, so that is efficiency. So you have to look at efficiency, and obviously economy, as I said, is related, right? Okay, I gave the example of the phone, I gave the example of the bridge. You have to look at the cost as well. Okay, so yes, I am getting more output, but I also invested like 2 million BD more. So it's not efficient in the end. Okay, and then it should be practical for the client, practical for the use, for the purpose. Okay, for the purpose you have built it. Okay, so you have a bridge which is again taking that example of the pedestrian bridge. So if you are building a bridge in Bahrain made up of steel, okay, maybe it's more efficient, less cost. Okay, so we have 3 things which are interlinked, which is science, then we have engineering, and then we have technology. Okay, so science works on understanding. Engineering works on using knowledge. And what I already said, using knowledge for providing solutions to real problems. Okay, and then we have technology, which works or which focuses on yeah, okay, very good. Tools and products, yes. Okay, so the last 2 are using science. Okay, science is telling you what is actually happening. Okay, science tells you what is happening. So if I heat something, what will happen to it? Okay, if I heat it to 100 degrees, what will happen to it? If I heat it to 200 degrees, what will happen to it? Okay, then the other two are using that knowledge. Okay, the other two are using that knowledge. Here we are using this knowledge to develop tools and products. Okay, again to solve problems, to facilitate human beings and so on. Okay, but the solution comes from where? From engineering. Okay, so you may have a tool, you may have a technology, you may have product, but you still don't know where and how to use it. Or most importantly, why should I use it? Okay, if I start using this, which problem will it solve? Okay, so that comes from where? From engineering. Okay, so engineering tells you how to use science and where to use it. Okay, if you just understand how to use it, you can build tools and products. Okay, but you still need the engineering mind and to have which problem will it really solve. Okay, otherwise people are building like games. That's it. Solving what? It's passing your time, right? Okay, so so you have to make sure that whatever you are building, it should be safe, affordable, reliable and suitable. So these things. Okay, I already covered this. Okay, so an engineer is looking to use the knowledge of science to develop products, and a scientist is using the knowledge, the previous knowledge, to build new knowledge. Okay, the difference between an engineer and scientist is both are using the knowledge, the scientific knowledge, the things which you already know. Okay, but engineer is using it to solve problems, to build something new, to give something to the society. Okay, and a scientist is doing it to build what? To do what? To have new knowledge. Okay, so a scientist will know something, and so for example, they have a lab. Like if you go to S40, they have their labs, right? They have the labs for chemistry, and so how did they build these labs? Using the knowledge which you already know, right? Now, why are they using it? They are using it to do more observations about science. Okay. So in science, the main aim is to know, to increase your understanding, okay, about the nature, about the people, about any type of species and so on, about the environment. Okay, so science is working on increasing the knowledge, increasing your understanding. Okay, while engineering is going towards how to use the knowledge for something which is solving a problem. Got it? Clear now? Okay, so one is going towards product or people, the other one is going towards knowledge. Clear? Okay. Yeah, okay. So we will do a small activity here as per their requirements. Okay, so engineer has to do what? They have to they have to act responsibly, wisely, okay, and yes, prioritize public. Okay, this is the trust which the people are putting on you. So when you are doing something, people think that you will act responsibly. Okay, when you know something is wrong, you will do something about it. When you cannot find a solution, you will tell them. If the solution has a problem, you will tell them. Okay, so you will act responsibly. If you made a mistake, you will try to correct it. Remember we talked about it in the last week. Okay, you don't blame others. Okay, if you did something, it went wrong, you will try to improve yourself, you try to correct yourself. Okay, so you will act responsibly, you will act wisely, you will think about what will happen if I do this, what will happen in the future. Okay, and you will look at all the options, and you will look at their results, their consequences. Okay, so I have 10, first of all, you will look for options, you will not say, okay, this is the only thing which I can do. No. Okay, so acting wisely means you are looking in future what can happen. Okay, and you are looking at all possibilities. Okay, not just one, not single dimension mind. Okay, and you are prioritizing others and their interest upon your personal interests. Okay, your priority is people. Okay, their problem. How can I best serve the community? How can I best serve the society? Okay, so your personal interests are low, others' personal interests are higher. Okay, so maybe you are looking to design a building and you want to, design the building which is like the state of the art, so that people know that, what's your name? Ali, right? Ali. So people will know that Ali designed this building. See how beautiful it is. Okay, and to make your name, you ask the client to spend more money. Okay, so now you are doing what? You are not putting the client's interest as the priority. It's your interest as the priority, right? Okay, you could have designed the same building with less cost, but you are asking him to put more money in the project just because of your personal interests. Okay, I gave a very there's something like it can happen. Okay, I want my name, but the other thing is, if my design costs 1 million BD, then my fee will be according to my design, right? If my design only 50,000 BD, then my fee is according to my design, right? Okay, so this is financial aspect as well. So, but anyways, when you are doing the design and the building and the maintenance and the operation, you are not looking for your personal interest, but you are looking at the interest of the client. And I gave you this list, right? Okay, now which one is the top priority in this list? Safety. Okay, so in terms of safety, even like I give the example of finance, right? Economics, the cost. So you may increase the cost of the building because of your fee or because of your name and so on. Okay, but when it comes to, so I can make it cheap, but I'm not making it because of my interest. Okay, but in some cases you increase the cost not because of your personal interest, but because of safety. Okay, so it's not like I am the best engineer because I always go for the cheapest solution. Okay, money saving is not the only criteria for engineering solutions. Okay, yes, wherever you can, you should. Where you can save the money of the people, the client, whoever it is. It could be a client, it could be the government, okay, and so on and so forth. Wherever we can save it, we will try to save it. Okay, but that doesn't mean that I will always go for the cheapest solution, because the cheapest solution may not be safe, it may not be efficient, and so on and so forth. We have to look at these things as well. Okay, so now coming towards engineering for students. So what are the qualities that we need to build in the student life to become good engineers? Okay, so the qualities which a student should try to build is responsibility, and these are things which I already mentioned. Okay, responsibility, judgment, integrity and accountability. Okay, these are the qualities which an engineering student should try to build in themselves, okay, in order to become a good professional engineer in the end. Okay, responsibility, I already talked about it. Engineer should act responsibly, right? What did it mean? Acting responsibly means what?
Don't blame the victim.
Huh?
Don't blame the victim.
Don't play the victim. Yes, you make your mistake, you own your mistakes. Okay, and you try to correct yourself. Judgment, you should try to develop your judgment, what is good, what is bad. If there are different solutions in front of you, how do I judge the suitability of each solution? Which one is good, which one is bad? How do I decide? Okay, so you have to develop your judgment now. Okay, so if I'm looking at an engineering project, if I'm looking at an engineering design, so how do I evaluate the design? Okay, how do I say that this design is good and this one is bad? What are the factors affecting it? Okay, so you have to develop your judgment, engineering judgment. Okay, engineering judgment, not there is an architectural judgment as well, right? Everything which is curved is good, something like this. If I put more colors in it, it will look good. So not that type of judgment, the engineering judgment. Okay, so a design may look very good, may not be good. Okay, so you have to judge it properly on the right factors. You have to act with integrity. Integrity means keeping your own honor, like honesty, for example. Okay, so if I'm on a road, I'm driving, there is no camera, the road is empty. Integrity goes to heaven, right? Huh? Integrity goes to heaven. Okay. When I go to heaven, I will get my integrity. Right now on the road, I'm driving on DLC, right? Huh? I am the Formula 1 racer here. I will show how fast can I go, right? Okay. So integrity means you are honest and you are responsible, not because of others. You are doing it for yourself. This is what integrity means. Okay. Your good qualities are because of yourself. You are doing your job properly, not because someone may catch you. You are doing it because I want to satisfy, because I am an engineer. Okay. I am doing it properly because I am an engineer. I am not doing it because somebody may catch me, or this design will go to an evaluator and what he will think about me, or the client is very smart, he will catch me. Okay, so even if the client is dumb, even if there is no evaluator, nobody else will look at your design, even then, okay, you will do your job properly with honesty and with completing all the requirements and so on. Clear or not? Okay, so integrity is your self-worth, your self-honesty. Okay, you are being honest because you want to be, or because you have a good image of yourself. Okay, then we have accountability. Accountability means being questioned. Somebody can question you. Okay, I am ready to defend myself. This is what accountability means. What I have done. Okay, if somebody comes and asks me, why did you do this? I have an answer. Got it? Okay. So if somebody says, why did you use wood here? We are using concrete in all the buildings. Why are you using wood here? Okay. Or why your windows don't have any glass panels? Okay. So I have an answer for that. Okay. And then again, going back to the previous point, that answer should be an engineering answer. Something related to cost, something related to purpose, something related to efficiency, safety, something like this. Okay, not just it looks good. Okay, or just I want to check it. Not like this. Got it? Okay, so accountability means that you are ready for being questioned. Okay, somebody takes you to the court and asks what did you do, why did you do, you have an answer for that. Clear? Okay, so why did I list them down? I forgot myself. What were these points?
Engineering for students.
Engineering for students. Okay, so like you have to develop these things from now onwards. Okay, in your exams, in your classrooms, in your assignments and so on and so forth. Okay, so you have to develop your responsibility. You have to be responsible of what you are doing. Okay, you cannot say, okay, I got bad grades because of this happened, that happened. Dr. Oneep was teaching and he was going very fast. I didn't know what he is saying. They just fire him from the university and so on. So the AC is not working, right? And these things. So you have to take your own responsibility. If you don't take it, nothing will happen. You will not improve yourself. You have to make your judgment. Okay, so you will see different courses, you will have different choices for your senior design project, for your training, and for whatever, for making your group and so on and so forth. Okay, so especially the groups, if I ask you to make the groups, it's like who is in most of my WhatsApp groups, right? I'll make a group with her or him. Okay, this guy is with me in 3 WhatsApp groups. This guy is following me on Instagram. Okay, so I make groups with them. Okay, this happens a lot, right? Okay, so not like this. Okay, so you have to judge what you are doing and why you should do this. Okay, so if you are, for example, you go in 3rd year, 4th year, whatever, they will ask you to choose different tracks. I hope they do. So why do you choose a track? Okay, just because my friend is taking it? Okay, you don't have any friends, so no option for you. Okay, so taking your senior design project, why are you taking it? Okay, I had like my whole batch of groups, my whole batch of friends. Well, okay, which project are you taking? You are taking this? Yes, I will take with you. Okay, and in our days there was no restriction, so we can have like 7 members, 8 members, no problem. Okay, so like the whole gang is there. Okay, so anyways, you have to make your judgment, and that judgment should be something technical. Okay, not on the basis of friendship or something. Okay, if he is good or the group can work and he's also your friend, it's good. Okay, but not always. Integrity. Okay, so if I say that you upload this assignment, you make this assignment, and I will not check the similarity, I will not do the plagiarism check and so on and so forth. Okay, so what do you do? What do you do? There is no similarity check. So everybody will do the same thing, right? All assignments same. Okay, and just to tell you a secret, this is why we do it. All assignments are same. We don't have to check it. Just look at the first word and the last word. Everything in between is same. Okay, but anyways, so integrity is, you got an assignment. You know if you do it yourself, you will learn. Okay, obviously you will learn. Okay, so if I do it myself, I will learn. So now you are doing it because you want to learn yourself. Got it? Not because the teacher will check it. Okay, but it's copied around. Clear? Okay, so this is what you have to develop from now. Accountability. Here it happens the other way around, right? Like, we are afraid if we showed you the marks, you will attack our offices, right? The whole gang will come. Okay. And you guys come in groups. Who was with me last semester in, I forgot the course, the quantity estimation. Yeah. They used to come in groups, not him. He is cool. Whatever. I don't care. So, but people used to come in groups. Okay. She got this much, why didn't you give me this much? Okay. So here it happens the other way. And I have to think 100 times before giving you 1 mark. Okay. But the other way should also happen. Okay. If I ask somebody why did you do this, they do not know. Okay. They come to me to ask me why did you give me 2 out of 10 here? And then I ask him, what did you do here? He said, I don't remember. What can I say? You don't remember what you did. Now are you asking me why did I give you 2 out of 10? So, okay. Coming back to the point, accountability means that if you're, again, it can happen in your projects, it can happen in your assignments, it can happen in your senior projects, okay, senior design projects. Okay, it happens a lot. It happens a lot. I have groups, we will do this, we will not do this. Why? Because we don't want to. This is not an answer. Okay? Accountability means we are not doing this because of this reason. Okay? Your examiner can ask you, your teacher can ask you in their project, why did you do this? Okay? So you should have an answer ready for that. And that answer should not be, I didn't have time, or I don't want to do it, I didn't know how to do it. Okay? These answers will not work in the real life. Okay, when people hire you, they are not expecting these types of answers from you. Okay, you may miss a very important solution. You may cost somebody thousands of BDs more just because you did something just without any reason. Okay, so your one random choice can cost somebody else their life. It can cost environmental damage or maybe lots of money. So you have to be careful when you are making these decisions, and you have to start taking care of these things from now onwards. So don't think of your exams and assignments as just things you are doing. Okay, they are trying to prepare you for these characteristics. Okay, so thinking like an engineer involves so when you are thinking like an engineer, the first thing you think about is it safe? Okay, whatever you are doing, whatever solution you are providing, you have to think of first thing is it safe? Okay, when you are trying to answer this question, another question arises, which is what assumptions you are making. What is the assumption? Yes, what is the assumption? It is written in all the question papers, right? Whenever you get an exam paper, it's written on the top. Assume missing data, right? Any data is missing, you can assume it. Assumption means what? Rules? No. Then? Yes, assumption means what? If I assume something, what am I doing? I'm thinking about the problem. Yes.
Making hypothesis for your idea.
Making hypothesis for your idea. Yes, this could be. If I assume a value, what am I doing? So I don't know the unit weight of cement. That's it. I assume it. So what do I do?
Make a guess. Make a guess.
Make a guess, right? Okay. I'm making a guess. Okay. So when I'm making a guess, what should I keep in mind?
It's close to the correct answer.
Yes. Okay. Your assumption? Yes.
But it's being green.
Yeah. You try to get as close to the real answer as possible, but you don't know the real answer. Okay. This is what we mean by assumption. Yes. It's a hypothesis. It's not a random hypothesis. It's not out of the box hypothesis. Right? It's just something which can be true. Got it? Okay? It's something which can be true. Okay? So same thing with the assumption as well. Something which could be real. Or it is as close to real as possible. Okay, so the only difference between assumption and the data is data I know. Okay, data I know the exact value. Okay, assumption is as or should be as close to real, but the only thing is I don't know it actually. Clear? Okay, so I will, for going back to the example of unit weight of cement, I will look at similar materials. Okay, materials which are similar to cement when I am assuming the unit weight of cement. Got it? Okay, you will not look at steel for assuming the unit weight of cement or wood or something like this. Okay, you look at things which are similar to cement, then you make your assumption. Got it? Okay, so thinking like an engineer means first of all you think about safety. Secondly, you are making an assumptions, so you have to think about, okay, when I say this will be the result, what am I assuming? Okay, what are the things I'm assuming, and you have to make sure that these assumptions are realistic. Okay, they are not real, but they are realistic. Okay, as close to real as possible. Okay, then something which we call as risks. If I'm making these assumptions, I'm making them realistic, but they are not real. Okay, so something can go wrong, right? Okay, so you identify the things which can go wrong in your project, in your design, whatever. Okay, so you try to predict or try to imagine what can go wrong. Okay, and this is very closely linked to your assumptions. So I assumed that my project will run for 1 year, and in that 1 year there will not be any very heavy rain. Okay, so my work will not close because of rains. It's an assumption, right? Do you know it will not rain? We don't know exactly, right? It's an assumption. Okay, so what can go wrong? I may have very heavy rain in Bahrain. Okay, and my work can close for 2 days, maybe. Or it will destroy my instruments, or it will destroy my equipment or something. Okay, so you identify the risks, things which can go wrong in the future. Okay, and the last thing is the results. Okay, so this is what I said earlier as well, not here, before that. Thinking wisely, right? This is part of thinking wisely. Okay, so when you are being wise, that means you are looking at the future outcomes. If I do this, what will be the effect of this solution or this product on the environment, on the people, on the society, and so on. Okay, so an engineer always takes decision on the basis of the results. Okay, and safety obviously is one of the results. So it's not only about calculating numbers. Okay, we have softwares to calculate the numbers. Okay, we can generate the codes to calculate the numbers. We have equations to calculate the numbers. Okay, so those numbers are not exactly providing you solution. They are just giving you data. Got it? Clear or not? Okay, so numbers which you are getting from the equations, from the softwares, this is just data. Okay, this is not real engineering. The real engineering is when you are looking at all these things. Okay, so when you will run the equation, when you will run the software, it will ask you for all the numbers. You may not have all the data, right? Then what do? You will make some assumptions, right? Okay, according to your assumptions, they may be true, they may not be true. So you are still getting results, but those results are based on the assumptions. Okay, so what if something goes wrong? What will happen to the to my calculations? What will happen to my design? What will happen to my work? Okay, and even if nothing goes wrong, what will be the end results? Okay, and you have to see the end results for the people as well as for the environment and everything else. Okay, so in your student life, when you are thinking about exam, so if I say we will have exam in the next lecture. What will be the first thing which comes to your mind? Tell me. What are the topics? Okay, I tell you the topics. Then, time of what? Time of the exam? Like how long or at what time? How long? Okay. What else?
Mark.
How many marks? How many questions? What else? Anything else?
Type of question like MCQs or
Type of questions. Okay. This is what you will ask me, right? What will be going on in your mind?
We're gonna watch out.
I am not judging you, right? I am not judging you. You can say anything you want. Yes.
Who gonna watch us?
Very nice.
how many days I should prepare myself for this exam?
Days or hours?
I don't know. I should know what is it for exam. It's final or it's just an midterm exam
Okay.
or it's a quiz.
So, who will be watching you? How much time you have got and what else?
Should I study?
Huh?
Should I study?
Should I study? Okay. Yes. What else?
We all have an exam to study.
Do I have time for study? See? I have weekend plans with my friends. Do I have time for study? Before I decide I have hours or days. Yes, what else? Nothing, right? That's all.
Am I prepared?
Huh?
Am I prepared?
How are you prepared? Tell me.
What-
How when do you feel you are prepared?
When I know everything in the class, I think I have in my mind what I.
Yes, yes. Okay. So lots of times we are thinking about exams and assignments. Okay. As how much material we have. Okay. And so when we are thinking about preparation, what do we mean by preparation? We want to prepare. We have got time or something. So how do we prepare for these exams and so on? What does preparation mean? Huh? Practice. Yes. What else?
Be awake.
Huh?
Be awake
Be awake
in the class.
in the class. Okay. You guys can sleep in my class, no problem. It's a challenge. It's not an invitation. I know you can. You cannot. I know my voice. Okay, so yes. How do you prepare?
Sleep.
Do you practice?
Sleep well.
Like for the topics, come on. Sleep well, eat well, drink well,
Write better.
live a happy life and just leave me alone. Yes, how do you prepare for the topic?
Rewrite them.
We will write them. You practice it. Yes.
Watch videos.
Huh?
Watch videos.
Watch videos.
See.
For what? You have to be clear.
See both exams.
Huh?
See what.
See past exams. Yes. Okay. So, lot of you are thinking about when you see the exam or when you are preparing for the exam, you are thinking about the topics as some sort of material which you have to like take in, and the day of the exam you put it out. This is how you think. If I practice more, okay, if I rewrite it, I will know, like your knowing is, I can write it word by word. Okay, if this question comes, I know from the last word to from the first word to the last full stop what to write. Okay, this is your, or if this is something solving, okay, so I know all the equations, I know all the steps. Okay, this is what we mean by preparing for the exams. Okay, but there was no point about understanding the topics. Yes, when you are going through the videos, when you are practicing it, it may increase your understanding, okay? But when you hear about exams and assignments and so on, okay, or when you are doing it, they are all given to increase your understanding of these things. Okay, if you know the procedure, just by knowing the procedure, you cannot do this. Okay, is the software responsible? No, it can do better calculations than you. Okay, does the software has judgment? No, it cannot select between different options. Okay, but again, the software will do the things faster than you, better than you in terms of accuracy and so on. But does it have all these characteristics? Does it have all these properties? Can it think about safety and so on? It doesn't. Okay. So what you are saying is you are preparing yourself to to answer the question. Okay. You need to prepare yourself to understand the question, understand the answers. Okay. The main aim is not to give the answer. The main aim is to give the answer so that you know. Okay. What does this question mean? Okay. And again, going back, if somebody asks you, why did you write this answer? So you will not say, okay, it was on slide number 9, this. Okay. You say, I wrote this because this is what happened. Okay. The last note, I have a course, Advanced Traffic Engineering. I have taught it maybe 3, 4, 5 times. Okay. In all those times, there was only one student who came up to me, okay, and he said, Doctor, you are putting a negative sign here. I used to give the same explanation to everybody. The negative sign means the queue is, the vehicles are having a queue. There's a traffic jam, so there's a negative sign. Okay. Nobody came up to me and he said, okay, but the negative sign is with the velocity. You are putting the negative sign with the speed. Okay, there's a traffic jam. Yeah, I understand. But why is the negative sign with the speed? So I had to explain it to him. Okay, so if you see, okay, it's a queue, we put a negative sign. Everybody will do it. Everybody will get the same answer. Everybody will get the same marks if they are doing it. Okay, but only one of them will know why we did it. Got it? And that person, when he goes in the field, he will be different from the others, right? Others are just doing it because it is the equation. Okay, but now he can make his judgment because he knows why it is happening. He can give the answers, right? Got it? Okay, so this is what you need to make sure about. And by the